this statement that an acid plus a base produces water and a salt. Okay? And I ask you to think about this in terms of something that's just an automatic thing. If I were to say to you, a certain carbon, hydrogen, oxygen fuel chain undergoes combustion, undergoes complete combustion, you would tell me that the result of that combustion would be what? Water and no. Fuel chain and oxygen in combustion produces water and carbon dioxide, right? It's automatic. So if you had that question on an exam that your carbon, hydrogen, oxygen fuel chain, like methane, CH4, completely combusted, you would know to add oxygen to it, an O2 molecule, to produce carbon dioxide and water. And go back and balance it, make sure it works. Or not, it works, but make sure it's balanced before you move on. Now in acid and base chemistry, we've got two different reactions that you kind of need to memorize. That's going to be that an acid and a base produces water and a salt. Now what is a salt? We covered this on Friday, I believe. What is a salt? It's not salt, common name for sodium chloride. That's not what we're talking about here. Water and a salt. Maybe I'll put that ahead. An a salt. As opposed to, if I put it in front, it's not a salt. That would be two S's, right? It's a salt. Acid and a base produces water and a salt. And the salt is Bueller. Bueller. Yeah, we just watched that movie again this weekend. Okay. What's a salt? It's any ionic compound. It's a metal and a nonmetal ionic compound. Okay, so a salt is an ionic compound. More specifically here, you need a little more information. When I first taught through this book, this wasn't obvious, but this is an ionic base. We're going to cover today that an acid plus a covalent base produces ions. So if I'm saying I have an acid and an ionic base that produces water and a salt, and then I say I have an acid and a covalent base that produces ions, what's going to be the key piece of knowledge you need to be able to perform, the key step you're going to need to be able to do? If I say I have an acid and this base, what does it produce? What are you going to have to be able to tell me? Whether or not the base is ionic or covalent, right? On the on your owns, for example, it had HCl3 and potassium hydroxide. Does anyone want to take a guess at which of these two is the acid? And tell me why. Good, Seth. Which is the acid? Yeah. Try again. Yeah, you mean this one, not this one, this one. Okay, why? Because this one's wrong? Leading hydrogen, okay, that's good. Okay, so leading hydrogen, and if I told you this is an acid and a base, leading hydrogen, likely the acid, why is this likely the base? If I said I reacted something with potassium hydroxide, why would you assume that this is going to be the base? Go ahead. The OH, right? The hydroxide ion. It's the most common base, ionic base. So this is a covalent molecule with a leading hydrogen. This is potassium and hydroxide, polyatomic ion. an ionic compound, because potassium is bonded to the hydroxide ionically, even though the OH is a polyatomic, right? It has a net charge of what? The OH molecule. Just -1. Right? And OH has a charge of -1. Potassium must have a charge of +1 to balance that out, so it must be a column 1 element. It is. Potassium hydroxide. So when I look at the acid and the base, for me to tell you, or for you to tell me, whether or not it's going to produce water and a salt or ions, I need to be able to figure out whether this is a covalent or an ionic base. And which is it? Well, I've got a +1 potassium bonded with a -1 hydroxide, meaning that that's an ionic base. Because it's an ionic base with an acid, the ionic base produces water and a salt. Right? So, in this case, I'm going to do the reaction arrow below, just for space. Remember we said that it's going to form water. It's H2O. Where does the water come from? It's from that hydrogen, and that OH produces the water. And what's left over? The metal from the base and the non-hydrogen portion of the acid, ClO3. Why? Because the non-hydrogen portion of the acid bonds with the metal of the base to form the water and a salt. So my salt here is this molecule right here. Potassium chloride is my salt and water. Now today they expand that discussion using ammonia. We said an acid and a covalent base produces ions. So let me see, they give us a let's go straight to 320. In the middle of page 329, we use H2SO4. Actually, does everybody have this copy down into your notes? I'm going to go ahead and erase it so I can use the whole length. Okay? All right. So again, as the example of the last one, we had HClO3 plus potassium hydroxide. So it's KOH reacts to produce H2O plus potassium chlorate. The hydrogen, the OH produce the water, the chlorate, and the metal. So my acid and my ionic base react to produce water and a salt. Next example they use is H2SO4 and 2 H2O react to produce 2 hydroniums and sulfate ions. Okay. How did I come up with these products of the reaction? Well, the first thing I had to do was look and identify which is the acid and which is the base. So again, in your reaction, they tend to give you the acids first. Second thing, you might have known that this is sulfuric acid. By its name, it has acid in it. Third, it has a leading hydrogen. Tell me something more about this acid. What do you see about it that's unique? Or more detail about its properties? Okay, though even though there's a sulfate in there, right, it's not attached type, it's a covalent molecule. Okay, so it's not bonded as a sulfate ionically with two hydrogens. It's not. It's covalent, the whole thing. Okay, but how many hydrogens does it have? Two, making it what kind of an acid? It's diprotic. Generally speaking, it's polyprotic. It says more than one. It's specifically diprotic. Is two. Has two to give away. Two potentially to give away. Now, water. We see water quite a bit. Is water generally an acid or is it generally a base? It's amphiprotic. So this is a polyprotic acid. Water is an amphiprotic substance, meaning it can be an acid or base, whatever is needed. In this case, we have an acid, so what will it probably act as? It will act as a base because we already have an acid. If we had water and a base, then water would act as the acid because it's amphiprotic or amphoteric, both terms. So we have a polyprotic, more specifically a diprotic acid, and water acting as the base. Is water ionic or covalent? Let's go ahead and I'll agree that that's the three-dimensional Lewis structure for water. Okay. Do you see bonds in there? It's not ionic, is it? It's covalent. Water is a covalent molecule. We know because we knew the three-dimensional Lewis structure. We also know that all the components in here are nonmetals. Since they're all nonmetals, it's a covalent molecule. So what we're looking at is an acid and a covalent base. Everybody see that? Okay. An acid and a covalent base. More specifically, a polyprotic, and even more specifically, a diprotic acid, and an amphoteric or amphiprotic base, in this case water, which is covalent. And an acid and a covalent base produce ions. Now here's the key. Notice on top of 329. Yes, sir?
You're right. Amphoteric's not a coproduct.
I won't, but I'll tell you where it is written out for you. It is back on page 319. This is where it says amphiprotic, and amphoteric is in the paragraph below that. So the definition is on 319. Okay. All right, now here's the deal. Notice the in blue on page 329. It says that covalent bases, they accept only one hydrogen ion. Say that another way, right? The covalent bases accept only one, what? Only one hydrogen ion, also known as, what's another name for hydrogen ion? A proton. Okay? So, covalent bases, whatever it is, they only accept one hydrogen ion. Diprotic and triprotic acids require more than one base to accept their ions. What they're saying there basically is the reason why there's a 2 here, and had we worked it backwards, the reason why this 2 is needed for this to be balanced is because each molecule of the base can only accept one hydrogen. Okay? See, this diprotic acid has 2 hydrogens to give away, but each molecule of the base can only accept one of them. So we need 2 molecules of water for every 1 molecule of acid to accept the 2 hydrogens, given the rule that the base can only accept 1 hydrogen. And here's the way it works out, because look at over here. This base has accepted 1 hydrogen. See that? It's gone from H2O to H3O, from water to hydronium, or heavy water. H2O has 2 hydrogens and 1 oxygen. H3O, it's got 1 more hydrogen. It's accepted one of these hydrogens into the base to become that ion. And by accepting a +1 charge, it goes from neutral to being +1 charge. The base, okay, so the base has accepted the hydrogen. The acid, because it's going to give up its hydrogens to the base to become hydronium, is left with the ion, SO4. And that SO4 is what's left over as a product of reaction. Okay? So again, just think the general rule. I have an acid-base reaction. In this one, it's an acid and an ionic base, which means we're going to have water and a salt. The salt is going to be the metal from the base and the non-hydrogen portion of the acid to form the salt. The second example, this is an acid and a covalent base. The molecule of the base is going to accept one hydrogen to become positive, and the non-hydrogen portion of the acid is going to become the free ion in solution. That's the content for today. Let's just work a couple examples. Okay? Work a few examples. In fact, example 9.3 in your book. Let's look at that together. Example 9.3 says, what reaction occurs between H3PO4 and ammonia? It's an acid-base reaction. We've got phosphoric acid and ammonia. Okay. So you ask yourself a question. That question is, given that it's acid-base reaction, given that it's an acid-base reaction, okay? Ask yourself, first of all, which question? What's the first question?
It's covalent.
Is the base ionic or covalent? Look at the base and tell me, are there any metals in the base? Is nitrogen a metal? Hydrogen a metal? Are there any metals? Therefore, it must be covalent, which means our result of the reaction is going to be ions. Okay. Given that the result of the reaction is going to be ions, I know that the base is going to accept one hydrogen from the acid. Each molecule of base is going to accept one of the hydrogens. This phosphoric acid is polyprotic. More specifically, it's triprotic, right? I'm expecting that I'm going to need 3 of these for every one of these. Do you see that? I've got to give away 3 hydrogens, and each one of these can take one of them. It can only take one of them to produce NH4. Right? So when one hydrogen from here comes over and gets added to this whole molecule, it produces NH4. And I'm going to need 3 of these to take all 3 of these. So one molecule of phosphoric acid needs 3 molecules of ammonia to produce 3 molecules of NH4. I take one away, I've got H2. I take one away, I've got H1. I take one away, now I just have what's my charge going to be? I've lost 3 positives from this ion, right? It was neutral, and I've lost 3 plus 1s. So my charge must now be 3 negatives. And does that make sense charge-wise? Well, let's look over here. What is the net charge of this side of the reaction? I've got a 0 net charge, and add to that a 0 net charge, which means I have a 0 net charge on the left. Let's look at the right. I have 3 plus 1s, which gives me a plus 3, and I've got 3 negative 1s. Excuse me, 1, 3 negative. 1, 3 negative, and 3 plus 1s cancel each other out. So I have a neutral left and a neutral right. In terms of the atoms being used, 3 hydrogens and 9 hydrogens for 12. 3 and 4 is 12. 1 phosphorus, 1 phosphorus. 4 oxygens, 4 oxygens. 3 nitrogens, 3 nitrogens. Yes, ma'am.
Why did you put 3 for the NH2?
NH3, because I knew that because each one of those can only take 1 hydrogen ion, 1 proton. That's the rule of covalent bases. The molecule can only take 1. How many do I have to get rid of? 3. So if I had only 1 molecule of ammonia, I could reduce this down to H2PO4. If I have 2 ammonias, I could reduce this down to H1. But since I need 3 to take all 3, that's its relationship. And that works out in the balance too. If all I told you was that I needed, let's say that we didn't know that number. We didn't look at this and say, I need 3 because because of this 3. Let's just go through and say, I gave you, and I'm confident this will work, but I haven't tried it. So let's walk through this one together. If I gave you the reaction, phosphoric acid and ammonia reacts to produce what? Just what does it produce? You could write that down right away, couldn't you? I mean, I'd sit down here and go, this produces NH4, right? But what would be left over would be H2PO4. See that? But I got 2 more hydrogens to get rid of. So you kind of say, well, I can reduce it even more. Let me add another 1 to 1. Let me add another 1 to 1. Work out. I can't go through. Let's try this. I might edit this out of the video because I haven't done this before. I don't know if it's going to work or not. But let's assume that that is what we came up with. We didn't have the charges, right? We just said, okay, what do I know? I know that this is going to become this, and I know that all these hydrogens are going to be used up to produce that. Let's balance it. Okay, hydrogens. How many do I have over here? 3 and 3 is 6. How many do I have over here? 4. So how do I balance it? I've got 6 on this side, and I have 4 on this side. I could multiply it by 6/4. That's, where's it, 4, 6? 6 on this side. I need 6, I've got 4. So multiply that by 6/4.
Can you reduce them? Can you reduce that? Or does it have to stay?
You can reduce it. It's the same thing. 3 halves, 1 1/2. So I need 1 1/2 of these, right? Because what that'll give me here, let's go reactants, products, hydrogens, phosphorus, oxygen, nitrogen. On the reaction side, 3, 6, 1, 4, and 1. Back me up, doing this on the fly. Product side, if I do 1 1/2, right? So hydrogens would be 6, phosphorus would be 1, oxygen would be 4, and nitrogen would be 1.5. What do I need more of? Nitrogen, right? I need 1.5 on this side. Right, so if I do 1.5 on this side, what's that going to mess up now? So the hydrogens over here now become, so this is 3, 4, 5, 6, 7 1/2. Wait, 1, 2, 3. Yeah, 1, 2, 3, 4, 5, 6, 7 1/2. I've got 1 1/2 nitrogens. Oh, excuse me, you got me. You let me go. Check me on this one. Let's see, phosphorus is over there. It's still 1. Hydrogens, 4, 4, 5, 6. Okay, good. So it's 6 hydrogens, well, because it's on that side. Phosphorus. Nitrogen's over here. Now I do 1 1/2 over here. This becomes 1 1/2. Hydrogens over here become 3, 6, that's 7 1/2. Is that right? Nitrogen's 1.5, nitrogen's 1.5. 3, 6, 7.5, 6, 1, 1, 4, 4, 1.5, 1.5. It's ugly, doesn't it?
Wouldn't it just be easier to do with full numbers instead of trying to use halves?
Maybe. It works out to be the same though, because ultimately, if we do fractional, then we'll have to go back through and multiply to remove the fractions from the coefficients. What am I missing? So we need more hydrogen on that side. See, what's going to end up happening is we're just battling between these two. See, because everything that we need is contained in those two molecules. It's going to be battling back and forth because when I want to add more hydrogens, if I double this, and it's kind of leading us where I went to before. If I change that to 3, the nitrogens become 3N and 12. I doubled that, basically doubled the two numbers. If I double this one to 3, 9, 10, 11, 12, hydrogens 3 and 9. Okay, 12, 3, and 3. Yeah. But you know what? Frankly, it's just easier the first way we did it, the very practical way of looking at it, of saying, okay, for every, let me go back to the basic. The basic is this. For every molecule of acid, I have 3 hydrogens to give away. Do you see that, first of all? For every molecule of acid, I'm trying to get rid of 3 hydrogens. Each molecule of base can accept 1 of them. So how many must I need to get rid of 3 of them? 3. I must have 3 of them because each one is going to take 1 of those hydrogens. The result of that is going to be all these hydrogens are going to be used up in those 3 and leave me with that ion left over. This one is going to, each one of these is going to accept 1 of those to become NH4. It accepts a positive, so it becomes positive. This one loses 3 negatives to become 3 negative. That's so much easier than going through the balancing routine. Okay. Because all I really did in the balancing routine was had to keep doubling it until I got to that number anyway. Because everything is contained within these 2 molecules. So when I up 1, I've got to up this one. When I up this one, I've got to up this one until we finally get to parity. So each molecule donates of the acid that donates its hydrogen, in this case triprotic. Each one of these requires its own base molecule to bond with. So these 3 need 3 individual molecules to produce these 2 ions. There's a second problem here in the book. What's the reaction that occurs between H2 dichromic acid and water? Okay, so dichromic acid and water. Water is amphiprotic, so therefore it can be a base. Since we have an acid and it can function as a base, we have acid-base chemistry. Okay? So given that we've got acid and a base, we look at the base. Water is covalent, so we would expect that this neutralization reaction, or the product of the reaction, would be ions. because this is a covalent base. What are the ions going to be? Well, this acid is diprotic. It has 2 hydrogens to give away. Each one of these can take one of them, so we're going to need 2 of them total to take up both of those hydrogens. And the product of reaction is going to be the base plus a hydrogen, so it becomes hydronium. See, I have 2 waters, and they become 2 hydroniums because each one of them accepts one of those hydrogens. And I also have the ion remaining, which is my dichromate polyatomic ion, right? The hydrogens from the acid, each one of them gets its own base molecule. The 2 base molecules form 2 hydronium molecules, and the non-hydrogen portion of the acid becomes its own ion in solution. Check my instrument book. Yep. Okay. Got it right. Yeah. Let's do the on your owns together. Last few minutes here. On your own 9.5. What's the chemical equation that describes the reaction between H2SO4 and ammonia? Sulfuric acid and ammonia. Notice that they didn't give you, well, they did give you the formula for ammonia. Oh, man, made it easy. Okay. Sulfuric acid and ammonia. Acid and a base. First question. What kind of base? What kind of base is it? Are there any metals? No, it's covalent base. So the product of the reaction is going to be ions. Each one of these acids can donate how many protons? 2. Each one of these bases can accept how many of them? 1. So how many do we need altogether? We need 2 base molecules to accept those 2 hydrogens. So what happens in reaction? The base becomes, it accepts a positive and becomes positive by virtue of that. It accepts 1 positive from the hydrogen ion, the proton, and the valence of the acid remains in solution. What reaction occurs between I think that's a font issue. Let me just check real quick. Yeah, it's a font issue. So you see in the on your own, that's why I switched over to using Times New Roman. On here, it could look like a capital H, lowercase l, but you're savvy enough now in chemistry to know that there is no element whose symbol is a lowercase l. And there is no element whose symbol is HL. So that must actually be a capital I, HI. Okay. So, what are we going to assume in this right here? Okay, I'm going to assume that this is an acid, has a leading hydrogen. That would lead me to think that way. Do we know what this acid is? It's not on our table, you know. But it probably is the acid. And if that is the acid, this is probably the base. Is water a base? Yeah. Is it an acid? Yeah. It's whatever's needed, right? So if this is an acid, water is more than happy to act as the base. Is this base covalent or ionic? Covalent. Since it's covalent, we're going to form ions. And the ions are going to be, well, first of all, how many hydrogens does the acid have to donate? 1, so it's going to be a 1-to-1 relationship, right? Every one of these can accept that 1. So it's going to stay 1 to 1. So the result of the reaction is going to be, first of all, I take my base, I add a hydrogen to it. Because it's a +1 charge added to a neutral, it becomes +1. What's left over? Iodine. Iodine is a common 7 element. Its ionic form, iodide. Iodide is a -1 charge. So that's a way to check that. Yeah, that's true. All right. So remember, you have an acid-base reaction. Identify the acid, identify the base. Is the base ionic or covalent? If the base is ionic, it's going to form water and a salt. If the base is covalent, it's going to form ions. Take the base, add 1 hydrogen per base to form a positive ion. Take the remainder of the acid, leave it in solution as the negative ion. You're free to work on review questions, practice problems until the end of the class, if there are no questions. Okay. Let me flip back there too and see what we should be able to do by now. Study guide, we can see review questions. You should be able to do first, second, third, fourth, 1 through 4. So review questions 1 through 4 are doable. Practice problems.
Are there any 20%?
You will be. You will be eventually. Practice problems 1 through 4. And let's go to the back. EPPs 1 through 6. For Wednesday. Okay. Wait, today's Tuesday, that's right. We'll make it Thursday. Good catch. Also, then, remember this short week, so Thursday is still chapel day? Like the day after tomorrow, not the day after tomorrow. So Thursday. That's usually the day, short weeks is usually the day when you rack up a lot of dress code write-ups and all. So I just want to remind you that. The week, well, it's 2 weeks from today.
Is that the last week of the grading period?
I'm sorry?
Is that the last week of the grading period?
Monday, 2 weeks from yesterday was the last day of the grading period. Yes, sir.
Can we, real quick, can we do one that has an ionic base?
Sure. Why don't we go back and look at, we did first on your own, the first thing we did, let's do one of the other ones. So if we go back to page 328, we did A as an example already, let's do B. Chromic acid and calcium hydroxide. Okay. So you're free to go ahead and work problems I'm doing on your own, 9-4 part B, as a review of an acid and, okay, it's a base, it's got hydroxide in it, but also notice what kind of a base it is. As a metal, as a polyatomic ion, it's an ionic base. So product of an acid and ionic base is going to be water and a salt. So the hydrogen and one of the hydroxides form water, but how many hydroxides do we have? 2 of them, right? So how many hydrogens do we need to match with those 2 hydroxides? Right? We need 2 hydrogens to match with those 2 hydroxides, so we're gonna need 2 of these. See that? So 2 hydrogens with the 2 hydroxides are gonna make 2 waters. You see that stuff? Okay.
So is it kind of the same thing as when we're doing covalent? It's just kind of like the
It's similar. You mean you're going to break them both apart. With the covalent base, you're going to add a piece to it. In the ionic, you're going to break them both apart and swap. See, because you're going to take the hydrogens, you're going to take the hydrogen out of this molecule, hydroxide out of this molecule, and form water. Then you take the leftover here and the leftover here to form whatever the salt is. The salt's going to be, you've got bromine and you've got calcium. So I can sit right here and say my salt is going to be some form of calcium bromide, right? Well, you can look at this too. How many bromines do I have? 2 bromine for every 1 calcium. I would suspect it's going to be this. That would take care of all my pieces. But bromine over here is column 7. So it's a -1 charge each. So 2 of them is a -2 charge. Calcium is a column 2 element. So it has a +2 charge. Bingo. There it is. So this is an acid and an ionic base form water and a salt. Acids and covalent bases produce the positive ion of the base and the negative ion from the remainder of the acid.
Yeah.
Then I would always, since I added the 2 and the 2, just go through and do a quick balance. 2, 4 hydrogens, 2 bromine, 2 bromine, 1 calcium, 1 calcium, 2 oxygens, 2 oxygens. It's balanced.